We begin by looking at the sequence 3, 4, 6, 9, 13, and we ask if we can continue this sequence in some sensible fashion. Well, people said that the pattern to this sequence was you add 1, then you add 2, then you add 3, then you add 4. Yeah, absolutely right. Okay, and then you would subsequently add 5 to 13 to get 18, then add 6 to 18, you get 24, and you could continue as long as you wish. I kind of wrote down an approximate algorithm of this. Says you start with your first number, assuming you're starting with your first number, you first add 1. Then you add the next whole number, which would be 2. So we add 1, then we add the next whole number, 2, to get the 6. And then we kind of loop this. We add the next whole number, that would be 3. We add that to get 9. We come back, add the next whole number, 4, and so forth. All right? Now, another way to look at this sequence that's very much related to the way most people did, and some people actually even kind of wrote it out this way. If you write the numbers 3, 4, 6, 9, 13, you can then subtract the 3 from the 4 to get 1, 4 from the 6 gives you 2, 9 minus 6 gives you 3, 13 minus 9 gives you 4. And at that point you would say, you wouldn't have these numbers there, you would say, okay, I'll bet you the next number that's going to be added is 5, or the next difference is going to be 5. And we see that if you do this number plus this number, you get this because of where they came from. 9 and 4 gives you 13 because 13 minus 9 is 4. Okay, so the next thing we would do to 13 is we'd add 5, and that would give us our 18. So I'm going to kind of purple that in to indicate that that's new. And then we'd add 6 to the 18 to get 24, 7 to that and get 31. And we continue on our merry way. So that's a little bit of information about this sequence and how we might think about it. Now, this is a chapter on problem solving, and there are various ways to solve this problem, but people tend to get this one okay. Next one can be a little more confusing, so we'll take a look at it.